Welcome to the fourth session of Module 4. In this session, we are going to discuss about operating system challenges in WSN and how to support concurrency, processes, event-based concurrency, components instead of processes, API, dynamic power management. What are the operating system challenges in wireless sensor networks? So if we looking at the usual operating systems, the goal is to make access to device resources and also protect the resources from concurrent accesses. So these are the system goals of usual operating systems. Usual means protected operation modes of the CPU. Hardware can be accessed only in these modes. And we need to use separate address spaces for each processes. And also we are going to use the memory management unit. But there is a problem with the microcontrollers. What is the problem with the microcontroller is, so these separate address spaces, memory management unit, okay. So these usual means are not available in microcontrollers. So we do not have separate protection modes. We do not have memory management unit. And this would make devices more expensive. And in turn, they also will consume more power. So what are the possible options we can use for wireless sensor networks? We can try to implement as close to an operating system on WSN nodes. In particularly, we should try to provide known programming interface. And it should support for processes and sacrifice protection of different processes from each other. So it's possible, but a relatively high overhead that will occur. One thing to remember is, in WSN modes, there is no lot many applications that are running. There is only single application running on a WSN node normally. So for that reason, it is not necessary to protect malicious software parts from each other. And direct hardware control by application might improve the efficiency. So currently the popular verdict is no operating system. We can use just a simple runtime environment. It is enough to abstract away hardware access details. And the biggest impact is unusual programming model. Here, how we can support the concurrency. Okay, so there is an issue to support concurrency in the wireless sensor nodes. So here we can see the sequential method. So first we consider we need to get the data from the sensor as well as with the transceiver. So sequentially how we can do is first poll the sensor. It is going to ask the sensor whether it is having any data that are present. So if that is present, then it is going to process that particular data. After this process only completed, again we need to pull the transceiver. So if there is data, then it is going to receive that particular packet. And again pull the sensor and process, again pull the transceiver and receive the packets. So this is the sequential manner of working with the sensor and transceivers. That is the simplest option is we are not going to use the concurrency, sequential processing of tasks that will be performed. But it is not satisfactory because consider that whenever it is pulling the sensor or processing the sensor data, some packet that is arrived at the transceivers, okay, so those packets or that particular data there is a chance of missing because the node or the operating system that is pulling the sensor but the packet is arrived to the transceiver. So that is the risk of missing data that will happen when processing the data. So for that we should use the interrupts. Why concurrency is needed is because sensor node's CPU has to service the radio modem, the actual sensors, and it also need to perform computation for application, and it also perform execute the communication protocol software, etc. So there are multiple tasks are there, so that's why the concurrency is needed. So in traditionally operating system that was using processors or threads. So we here based on interrupts, the context switching that we were going to use. But this is not available because it will burden the memory, so memory will be overhead, and also for the execution also it is overhead. So see in this figure we handle sensor process, handle packet process. So switching from handle sensor process to handle packet process, so we are going to use the switching. So if the receiving data or the data, so we need to process that is smaller, and this switching from process to one process to another process, that takes much time. So then it will create the overhead. Why? Because the content is small, but switching between the processes that will becomes more. So that will create overhead in terms of memory as well as executing to switch from one process to another process. Next is event-based concurrency. Switch to event-based programming model. So it will perform regular processing or be idle, react to events when they happen immediately. For that we are going to use the interrupt handlers. So whenever the event that is occurred, the interrupt that must rise. So that interrupt handler that will taken care whenever the event that is going to be occurred. Problem is must not remain in interrupt handler too long. So if it is remains in the interrupt handler, there is a chance of losing the events. Only save data, post information that event has happened, then return. That is the thing we need to do. And another principle we are going to use is run to completion. Once it is started, so our aim is to finish that process fully. or to complete it. So that is called as the run to completion principle. So here we, in the event based concurrency, we are going to use the two contexts, one for handlers and one for regular execution. So consider for the sensor nodes. So there will be two handlers. One handler is sensor event handler and another is radio event handler. Sensor event handler that will handle the sensor data to receive to sense. Radio event handler that is with respect to transceivers. And the processing that will be takes place depending on from which handler the information or the data is arriving. So in WSN we are going to use components instead of processors. What is the main difference to processors is components does not have an execution and components access the same address space. No separate address space is needed and no protection against each other. API to an event based protocol stack. Application programming interface to an event based protocol stack. In usual networking API, we can use sockets. Here the issue is we need to block the calls to receive the data. We are talking in terms of networking API sockets. So here what happens is ill-matched to event-based OS. Also, the networking semantics in WSNs not necessarily well matched to socket semantics. Therefore, API is also event-based. For example, tell some component that some other component wants to be informed if and when data has arrived. The component will be posted an event once this particular condition is met. Next is dynamic power management. Exploiting multiple operation modes is promising. Question is when to switch in power save mode. What is the problem that is going to occur is time and energy overhead associated with wake up, when to wake up. Whether is it necessary to make the node to go to greedy sleeping mode. Okay, so actually greedy sleeping mode is also not beneficial because it takes time to active, more time, okay, and energy also to wake up. So that is what the problem. So time and energy overhead that will be associated with waking up the node if that node is in the deep sleep mode condition. Another option we can use that is the scheduling approach. So question is how to control dynamic voltage scale. We already know that we can aggressively perform functions or computation by doing stepping up the voltage or frequency to the higher rates. We can perform the task in the faster rate. So if there is a deadline to meet in particular time, this particular task that has to be finished, so then we are going to step up the voltage or step up the frequency so that we can meet the deadline. Or trading of fidelity versus energy consumption. If more energy is available then we can compute more accurate results. So this is one of the example polynomial approximation. To perform polynomial approximation, start from high or low exponents depending on where the polynomial is to be evaluated. And this is the reference I have used. And thank you.